Hello there, Mr. Sutton here, bringing you this AB Calculus 311 lesson on derivatives of logarithmic functions. In this one, we will be finding derivatives of logarithmic functions and also taking derivatives of functions with variables in both the base and the exponent, which is actually called logarithmic differentiation, which is different than taking derivatives of logarithmic functions. To start this lesson off, let's come up with some derivatives of logarithmic functions. So I'll give you the first one. Here's the derivative for any log. So if you're taking the derivative of log base b of x, that's going to be 1 over the input, which is x in this case, times the ln of your base. Using this idea, see if you can figure out the derivative of ln of x. Pause the video, give it a shot. All right, so this is log base e. So we're going to have 1 over x times the ln of e. Well, what's the ln of e? It's just 1. So this just ends up being 1 over x, which is kind of nice. So using our definitions of log derivatives and basic derivative rules in general, see if you can come up with the answers to the next two examples. Pause it, give it a shot. All right, so for this one, we're using the rule 1 over something. In this case, that's going to be a 1 over x plus 2. And if we're trying to multiply by the derivative of the inner function here, well, that's just 1, so we don't have to write anything. Now for this next example, we're going to have to use our general log rule. So we're going to have 1 over the input, so that's 1 over x squared plus 2x, which pops out, times the ln of the base. The base in this case is 7, so we're going to have ln of 7 down here. And now we have to multiply by the derivative of the inner function using our chain rule. So that's going to be 2x plus 2, and since that's automatically in the numerator, we're just going to stick that up top. So as we saw in the last two examples, chain rule is still a thing when we're doing derivatives of logarithms. However, we can sometimes avoid it. On these problems, we're going to see that simplifying first with laws of logs can often save you that extra step of using the chain rule. Using this idea, see if you can simplify these first and then take the derivative. All right, so for example 3, we're taking the ln of e to something. Well, ln and e cancel out, so you really just have the function y equals sine of x. And the derivative of that is just cosine of x. So that's a lot nicer than doing derivative of ln, derivative of e, derivative of sine. Now on this next one, a good thing to do here would be to rewrite this using an exponent. I can write this as log base 4 of x to the, this is negative 1/3, and then using my log rules, I can pop out that exponent, that negative 1/3, to be out in front. Well, once I've done this, I'm just taking the derivative of log base 4 of x, which is 1 over x ln of 4, and we still have that negative 1/3 out in front. So we have a negative, we have a 1, we have a 3 in the denominator, along with the x and the ln of 4. And now we come to the final boss battle, trying to take the derivative of y equals x to the x. Now this is kind of a tricky one because this doesn't follow any of the rules we've seen so far. Power rule doesn't work because we have a variable in the exponent. And exponential rule doesn't work because we have a variable in the base. We have a variable in both places. So in situations like this, we use something called logarithmic differentiation. Now you might think you were doing that the whole time. You weren't. Logarithmic differentiation, as opposed to just taking derivatives of logs, involves starting by taking the ln of both sides of the equation. And this is a really good move because that'll get the variable out of the exponent. So on the left side, we have ln of y. On the right side, using our pop-out rule, we have x times the ln of x. And at this point, we're just going to use implicit differentiation going from left to right. So on the left side, we have 1 over y times dy over dx, because y is an inner function when we use impdiff. On the right side, we've got a product rule. So we're going to use our box and ribbon here. I have factors of x and ln of x, and those derivatives are going to be 1 and 1 over x. Multiplying this out with the ribbon, we've got ln of x plus whatever x times 1 over x is. That actually is just 1. All right, so we're almost there. We have to isolate dy over dx, though. To do that, we have to multiply both sides by y. So we have y times all the stuff that was already on the right side. And you might think you're done, and most of the time you would be if this were just normal impdiff, but more often than not on these problems, you have to get everything in terms of x. In this case, the directions said in terms of only x, but often on multiple choice, we have to do that too. So if you have to turn this y into something with x's, where do we get that from? Well, if you look back at the original, it says here y equals x to the x. So you're just going to replace y with that original expression. So we can write this as x to the x times ln of x plus 1. And we're done. So that's it for this one. Until next time, dare I say it, Mr. Sutton logging off.